Okay, we're going to finish with number 11. So the first thing I did is it's the tangent of the square root of 3x minus 1, and I'm going to use change that to an exponent. Hopefully by now that's second nature to everybody. I want to point out something. I don't know, I said this in the end of the last video, but this is different than if the entire function were under the square root. In fact, I might, let's see, the next one, I'll see if I can either point it out with this problem or we'll do another problem. Anyway, you want to treat these differently. This one, the entire function is raised to the 1/2 power. And we would use the chain rule twice, once for the tangent and once for what's inside. Here, we're only going to use the chain rule once, and it's right here, the 3x minus 1 to the 1/2 power. We're not going to use it twice because tangent isn't being raised to any power. Okay, so let's just go get right to it. Since tangent isn't being raised to any power, it's just tangent to the first power. Then y prime, I can go right to secant squared of basically whatever's in here. So secant squared of 3x minus 1 raised to the 1/2 power. And now I'm going to find the chain rule of whatever's in here. And I'm going to run out of room, so I might go to the next line. Times, actually I'm going to start in the next line, times 1/2 times whatever's in the parentheses minus, so that, and then to the negative 1/2 power, and then the derivative of what's in the parentheses, and in this case it's 3. Okay, let's clean this up. My final answer looks like this. Y prime equals, looks like I'm going to have a fraction bar. I'm going to have some stuff in the numerator and some stuff in the denominator, so we can actually even highlight. Because this is being raised to the 1/2 power, this whole thing is going in the denominator. Okay, so it's going to be the square root of 3x minus 1, and that takes care of that. And then 3 times secant squared of the square root of 3x minus 1. And that takes care of, let's see, that takes care of that, that takes care of that. There's the 3. Oh, and this 1/2. So this 1/2, that's just 1 times 1 over 2. I don't have to put the 1, but I'm going to put the 2 on the bottom. And that's the answer. Okay, let's take a look at number 12. Okay, let me switch colors. Okay, number 12. So this one you might be inclined to distribute here. You can't, because it's the secant of all of this together. Okay, so again, you're going to treat this as if this is the secant of x. This is just one big quantity. So don't be intimidated. This quantity happens to be a trinomial. You want to treat this as if this were secant of x. The only difference is we're going to apply the chain rule because the derivative of x is 1, but the derivative of what's inside these parentheses are different. Okay. Okay, so y prime equals, again, secant is not being raised to any power. I can plunge right into the derivative, which is, this is going to be long only because the derivative happens to be long. Secant of x squared minus 2x plus 3 times tangent of, I know this is bad form, but I just ran out of room, x squared minus 2x plus 3. And now I'm going to find the derivative of what's inside the parentheses. So that's times 2x minus 2. And I'm done. So I'm just going to clean this up a little bit. And y prime equals, I'll put the 2x minus 2 in the front. And let's see if I can fit this all in one line. Times secant of x squared minus 2x plus 3 times the tangent. I'm going to have to go in another line. Tangent of x squared times 2x, minus 2x plus 3. And that's the answer. You're done. It's that easy. Okay, let's turn to number 13. Okay, odd one.